is just so interesting. I don't know about you, I'm loving it. Now let's go to C. Want to finish this off? Want to just kill it off? Let's go see the last two. I mean, we've got now sec squared, and then we have this 1 over x squared plus a squared. Let's talk about these two. So what is happening here on sec squared? Well, we start with some derivatives, okay? To remember, from the common derivatives table, okay? It's not something we've done already. How do we get sec squared? Who do we differentiate? Tan. So I can say, okay, what is the derivative of tan x? It is sec squared x. Then I can say, what is the derivative of tan f of x? Well, this is now a composite function. So easy. So first I differentiate the outside. In other words, I differentiate the tan, because tan is on the outside. And it's just going to give me sec squared. So it's going to be sec squared of what? Of f of x, okay? Remember, the inside doesn't change. Then you multiply by the derivative of the inside. The derivative of the inside is f dash x. So this is going to be f dash x sec squared. So what about if I now differentiate tan of ax plus b, okay? What am I going to get? Well, if you differentiate tan ax plus b, you're going to first get sec squared ax plus b, okay? Then we multiply with the derivative of the inside, which is the derivative of ax plus b is a. So it's a sec squared ax plus b. Now let's go to now integrals, okay? Because for integrals, the one they want you to know is the integral of sec squared. So if I do sec squared x, what am I going to get? If I integrate sec squared x. Remember, for these three guys, we did it for sine, we did it for cos, we're doing it now again. If you want to integrate them, go to the common derivatives table, look for them, then move backwards. Look for them on the right hand side. So here I look for sec squared. I want to see, what do I get when I integrate him? I found him, and I move back. I'll get tan, okay? Because integrating is like I'm asking you, who did I differentiate to get this guy? So in here, I can see that if I integrate sec squared, I will get tan. So there's going to be tan x. I mean, you can put the constant of integration c, which is, I mean, something I've been leaving out a lot, you know? You can put the constant of integration c on each and every one of these. Don't forget to. Sorry for that. I mean, right. Don't forget to put the constant of integration c, and we'll see the cases where it doesn't work. But anyway, you need to put the constant of integration c after integrating everything. When you're done with the job, remember to put the constant of integration c. So now, what about if I'm now doing sec squared f of x? What am I going to get? Well, when you're integrating and you have this type of thing, first of all, you ask yourself, who did I differentiate to get tan? And to get this is going to be tan. So it'll be tan f of x. But then we then divide by the derivative of the inside. What's the derivative of the inside? It is f dash x. So it is 1 over f dash x, because the inside is this guy. Is the inside. So we differentiate him, we divide by that guy. This is going to be, then you put your plus c at the end. Then now what about if it's sec squared ax plus b? This becomes very easy, right? Because what am I going to do? If I integrate sec squared, what do I get? Tan. So it's going to be tan ax plus b. Okay, remember the inside doesn't change. Then we divide by the derivative. So it's going to be times 1 over, that's the same as dividing. The derivative of this, it's a. So it'll be 1 over a. So we can just say this is going to be 1 over a, tan ax plus b. Then at the end, we put your constant of integration c, and you'd be done. And these are the ones we do for sec squared. All right, so now from here, we're going to the next thing. And that next thing is just going to be that last guy. So this is the one to remember, please. This is the one to remember. Now we'll go to the last thing, the very last thing, and we would be done. We just want to go and talk about tan inverse. And you are done. All right, goodbye for now. See you in the next one.